viewers, we are in building 220 at the Brightlands campus. This building houses part of the offices and the labs of Brightlands Materials Center. I would like to invite you on a short lab tour to get a look behind the scenes and learn more about Brightlands Materials Center lab facilities. Bastiaan.
Hey Margot.
I was wondering, can you tell them a little bit about yourself and what's your role within the Additive Manufacturing program?
Sure. My name is Bastiaan. I work in the Additive Manufacturing group as a research engineer. I have a background in material science, and for about 7 years I'm working on the topic of additive manufacturing. Within the Brightlands Materials Center I started mainly on thermoset-based materials for dental applications. But currently we expanded to basically any polymeric additive manufacturing technique.
Interesting. And what are you working on right now?
Currently I'm maintaining and cleaning one of our additive manufacturing machines. We do a lot with continuous carbon fiber and we have several printers for this. This one more specifically is related to the sensing application we try to develop. This allows us with our custom tool to make a printed part which has a sensing functionality in it. That is actually one of our demonstrators related to sensing. There are 3 beams there. They all have a sensor in it, but you can press some of them and then you can see the response of the signal on the screen.
There it is. That's great. Thanks, Bastiaan.
You're welcome.
I will leave you to your work right now.
Okay, have a nice day.
We are now one door further in one of the Sustainable Buildings labs. Hi Janique.
Hi.
Could you please introduce yourself and tell a little bit more about your role in the Sustainable Buildings team?
Yes, I'm Janique and I have a background in both chemical engineering and bio-based materials. Together with the team we are working on smart solar control coatings and pigments for energy efficient glazing in buildings. We are developing smart windows which are able to block infrared light in summer and transmit it in winter. In this way a constant temperature can be maintained in the building, thereby decreasing energy consumption and reducing CO2 emissions. Well, I just filled this quartz tube with our synthesized starting material and I'm going to thermally treat this powder in the rotating tube furnace so that it will get its desired properties and purity. If you want, you can follow me to the furnace. In this device we crystallize our material at high temperatures and due to the fact that the tube is rotating, the heat distribution will be very good. After the oven procedure, the powder will look like these very sparkling pigments. However, these pigments are still quite big, as you can see, which is of course not desired when applying in glass paints. Therefore, we use a bead milling device to reduce the particle size. So in this device we mill our particles that I previously showed you to nanoscale level, so approximately 100 nanometers. In this size regime we can make sure that the visual properties of the windows won't be compromised. These particles can then be implemented in polymer films to use in, for example, safety glass. This is such a polymer film. And these polymer films can then be used to laminate glass, such as you see here.
And is this the only application for these pigments?
No, similar pigments can also be applied in solar panels to enhance their efficiency and lifetime. Furthermore, these pigments can also be applied in thermochromic coatings.
Okay, very interesting.